Okay, so now we're going to look at seeing light and mixing color. So the first thing we're going to look at is what these terms mean. You can read the vocabulary as well as I'm going to say it. So opaque is absorbs or reflects all light. Transparent just allows light to pass through completely, and translucent allows some light to pass through. So I have a vase here, and the vase, I'm going to put something in front of it, and you're going to tell me, is this opaque, transparent, or translucent based on those terms? Well, if you said opaque, then you have it right. Now we got one more we're going to go with. Let's do that one right there. Is that opaque, transparent, or translucent? If you said translucent, then you have it right. Okay, and obviously, let me go back here, that's transparent. So let's go to the next slide, which is regarding seeing colors. White light contains all the visible colors. We went over this, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. Okay, so in white light, an object reflects the colors you see and absorbs all other colors. So if you see a leaf, you're seeing green because it's reflecting green, but it's absorbing all the other spectrum of colors that you don't see. We're going to talk about the eye now. And of course, the retina contains rods, which are activated by black and white images during dim light situations. And then, of course, there's cones that see in color. And there's three different types of cones. There's red cones, there's green cones, and there's blue cones. Red absorbs yellow and red. Green absorbs yellow and green. And blue absorbs blue and violet. So let's look at the banana real quick. And you tell me which cone or cones are going to be activated. Well, if you said red and green, then you're correct. It's going to stimulate the red and green cones because red and green cones are both stimulated by yellow. So now look at the snowman. The one thing that you should notice is that the snowman has blue in it, so it's obviously going to be the blue cone. It has green in it, so it's obviously going to use the green cones. But what about the red and the yellow? Well, the carrot is red, but also one thing to keep in mind is the snowman is white, so therefore it's going to activate all red, green, and blue cones because white light is made out of all the lights. It's kind of interesting. Okay, so I want you to look in at this image and tell me what number you see. Okay, so if you saw the number 57, then great, you're not colorblind. What is colorblindness? Well, it's when one or more sets of cones does not function properly. So this is the test for red-green color blindness, which is one of the most prominent types of color blindness. So how do you mix colors? Well, you got to remember there's two different types of things we have to look at. We have to look at, are we talking about lights like the light you shine on the wall, or like pigments that you paint with? We're going to look at lights like you shine on the wall first. So there's three primary types. There's red, green, and blue. It's done by an additive process. In other words, you're going to shine another light in it, and it's going to change the color, and you'll see this in a minute. And it's combined to form white light. So here we have a red, a green, and a blue light. Notice that where the red and the green overlap, yellow is created. Notice right over here where red and blue is shining together, right there in that corner, right there in that corner, it creates magenta. Notice where green and blue, you get the cyan color, right? And notice where they all come together, it's white. So that's kind of interesting. An example of this would be your monitors. If you've ever got in, like for instance, you're using Word or PowerPoint and you've wanted to change the color of a background, you can get into these some of these menus that you can change the different tones of red, green, and blue. That's an example of where you might see this at. Another thing that you might see it at is whenever you're using filters, and a filter is just a transparent material that absorbs all light color except for the light color that you're trying to get through that to show. So notice we have a yellow light here, and of course, what two primary colors is yellow made out of? If you said red and green, then you're right. So what happens if we put a red filter on there? What color will show up? Well, if you said red, then you're right. Notice If you have a yellow light and you put a red filter in it, it's only going to allow red to go through it. Does that make sense? Now, what happens if you put a green filter on it? It's only going to allow green to go through it. What happens if you put a blue filter on it? What light will go through? Well, if you said none, then you accurately noticed that yellow light is made out of red and green, not blue. So no light will get through if you're trying to use a blue filter with a yellow light, because blue isn't part of that light to begin with. Okay, so now we're going to look at pigments, and pigments is just a colored material that absorbs and reflects different colors. Primary pigment colors include cyan, magenta, and yellow. And this is a subtractive process, or subtractive colors. Whenever, unlike light, whenever you put all light together, you get white light. When you put all the pigments together, you get black pigment. So that's something to keep in mind. An example of this would be like ink cartridges. Now, what I want you to do is I want you to write down, just real quick, just compare and contrast what you see between light and pigment. One other thing I want you to know is when you're mixing pigments, the color of the mixture is the color of light that both pigments reflect. Okay, so this is an interesting thing here. What I want you to do, and don't think it's silly because it's not, we're going to spend about a minute just looking at this dot right here. Okay, so just look at it, and this will help. Hit pause if you need to, but this will help if it's in a pretty dark room. So just stare at that image just for a second. Stare at the dot in that image. Don't take your eye off of it. Just stare at it. You'll get a kick out of it whenever you see this. It needs to be in a rather dark room though, so just keep staring. Okay, so now what I want you to do is I want you to write down what you saw. Okay, so what happened there is what's called a negative after image. This is what happens whenever one set of cones get tired and the remaining cones produce an image in the complementary color. It's pretty neat, and it happens to us all the time, and we don't even realize it sometimes. Okay, well, I hope that helped you with this subject, and thank you for watching.